Welcome to the deep dive. You know, for years, the promise of a flying robot, that sort of ubiquitous personal drone, has felt, well, amazing on one hand, but also absolutely terrifying.
Hmm.
Because when a machine with rigid propellers and a hard frame gets close to your face, your first instinct is not trust.
Not at all.
So today, we're taking a fascinating look at a future for robotics that completely flips that script, making flying robots safe, quiet, and even huggable.
Huggable, yeah.
We're plunging into a stack of research on a novel type of floating companion that I think fundamentally redefines what safe and social can even mean when machines are in our personal space.
And that's really the crux of the problem, isn't it? The whole field of human-robot interaction, or HRI, has been kind of stuck when it comes to aerial robots.
Stuck how?
Well, traditional flying robots, mostly quadrotors, they just inherently generate fear, stress, all because of those fast-spinning propellers, the hard structures, and just the sheer noise.
Right. They're built for speed and carrying things, not for gently interacting with a person inside their home.
Exactly. So the designers behind this project, which they have named Cuddle-Fish, they had a very specific mission
Okay.
to create a soft, lighter-than-air, flapping wing robot, one that could overcome all those issues and, this is the key part, foster effective physical interaction.
Affective, as in emotional. We're talking about turning a really anxious interaction into one of, like, spontaneous affection.
It sounds like pure fantasy, I know, but the design is just this beautiful example of bio-inspired engineering meeting a very real human need for safety.
Okay, let's unpack the engineering first, because building this versus a quadrotor's seems like night and day.
Oh,
It's a
yeah.
total shift in how it moves.
It's a foundational shift. You have to ditch propellers completely and instead embrace bio-inspired flight. Cuddlefish uses flapping wings,
Okay.
and that immediately creates a soft, incredibly quiet, and totally touch-safe alternative. And the inspiration isn't even birds, which is what you'd expect.
Oh,
It's marine life. Think manta rays, sea turtles, even whales. They move with this low-frequency pectoral fin flapping, just gliding through the water.
so cuttlefish is basically swimming through the air.
In a sense, yes, it mimics that slow, wave-like movement.
So that solves the softness and safety part, but that takes us headfirst into a physics problem, right? Buoyancy.
Mm-hmm. You're using helium?
And helium is, I mean, it's notoriously bad at lifting things. The sources say 1 liter of helium lifts about 1 gram. That's it.
Precisely. And that one constraint has historically made floating robots just enormous.
Right, I've seen pictures of those legacy projects, the Air A, the Air Penguin. They were incredible, but they were huge.
Massive. Some had wingspans up to 4.2 meters. You are not casually inviting something the size of a small car into your living room.
No. And for cuttlefish to work as a companion, it had this one non-negotiable design rule,
It
right?
had to fit through a standard interior door frame.
Which are typically, what, 0.7 to 0.9 meters wide? Not a lot of room to spare.
So the engineering miracle here is just how much they downsized it. They pulled it off by simplifying the propulsion mechanism, actually taking inspiration from underwater robots. They found that a single degree of freedom flapping mechanism was efficient enough, and that optimization let them shrink the whole thing down dramatically.
So just how small are we talking? What's the final weight on this thing?
The Cuddlefish robot's total weight is a shocking 70 grams.
70 grams.
Yeah, less than a deck of cards. Its
Uh-huh.
maximum wingspan is 0.78 meters, so right at the edge of that doorframe limit.
But it gets through.
Yes, and here's the elegant part. For tight spaces, when the robot lowers its wings all the way down, its width narrows to just 0.45 meters.
It tucks its own wings in to get through the door. Wow. That shows just a meticulous level of design. That's not a small tweak. That's genius.
It really is. The propulsion is just two tiny, lightweight servo motors, and the wings themselves, they're the crucial safety part. They're soft, made of aluminum-coated nylon film, and they flap so slowly,
How slowly?
between 0.3 and 1.5 times per second. I mean, even if it bumps into you, it's designed to be a cushion. It poses zero threat.
So they've nailed the safety and the stability. Which leads to the first big question for their user study. How do people actually feel when this soft, quiet thing is flying around in their personal space? This is their research question 1.
Right. So they recruited 24 participants, and for the study, they used a technique called the Wizard of Oz methodology.
Wait, let's unpack that. The Wizard of Oz. It sounds like there's a person behind a curtain pulling the strings.
That's exactly what it is. It's a standard method in robotics research. It means an operator, the wizard, is controlling the robot remotely to simulate perfect autonomy.
Yeah, and why do that?
Because you want to test the pure human-robot interaction, the design, the movement, the feeling, without the distraction of, real-world glitches.
So if the robot bumped into a wall because of a software bug, the person might get mad at the robot itself, and that would skew the result.
Exactly. You're testing the concept, not the current state of the code.
That makes perfect sense. So they had this wizard control it through 6 demos designed to test people's comfort zones, things like fly towards or circle around.
And even a potentially more disorienting one, spin overhead.
And the results were pretty stunning, right?
Oh,
Especially when you compare it to how people react to rigid drones.
completely stunning. Participants consistently said they felt safe, pleasant, and had very low stress. The anxiety we associate with flying machines it vanished because the physical threat was gone.
And this is where it gets really interesting for me, the emotional response. They use psychological metrics like the valence and arousal scale to measure feelings before and after.
Yes. And for listeners, valence is basically a measure of pleasantness, how good or bad you feel. And they found a statistically significant increase in valence scores after people interacted with the robot.
So it's not just a neutral response. People actually felt better, happier after the experience.
It's a profound shift. From a baseline of maybe some apprehension to actual enjoyment, the soft design just fundamentally changes the psychological landscape of aerial HRI.
It's clear that the organic movement, being inspired by manta rays, it really translates to a soothing feeling. I think one person in the study said it was like being in an aquarium, watching something calm.
That organic quality is absolutely key. But the type of movement did still matter. They found that movements people saw as playful or engaging, like flying towards them or circling, were highly preferred.
And conversely,
The spin overhead movement, which is maybe a bit less familiar, less readable, I guess, it was seen as significantly less attractive. People need to feel like they understand the robot's intent.
so the choreography, the way it moves, has to feel natural and intentional to really be accepted.
Right, it's not just about being safe.
Okay, so if they've conquered safety and pleasantness, that leads us right into research question 2, and this is the section that truly blew me away. Are people willing to physically interact with this robot?
And the answer was a resounding and I'd say unprecedented yes. For a flying machine, these results are groundbreaking.
So what was the number?
Out of 24 participants, 22 of them, that's 92%, willingly engaged in touch-based interaction. And here's the kicker. With no prompting at all. They just did it spontaneously.
92%. That is incredible. We're talking about people initiating touch with a flying machine, something we are almost universally trained not to do with drones.
And the type of touch was what was so critical. It wasn't just, poking it or batting it away.
Yeah.
They saw a whole spectrum of affectionate behaviors, things you'd normally only see directed towards a small child or a pet. Participants were patting it, stroking it gently, hugging it, cradling it in their arms, even touching it with their cheek or tickling it.
Patting, stroking, hugging. These are acts of real spontaneous affection for a machine made of nylon and helium.
This level of physical connection is unheard of. It transforms the machine from just a functional device into what the researchers call a playful companion.
And it seems like the soft design created an emotional shortcut. Since it was safe to touch, people immediately started ascribing a personality to it.
Exactly. Based on its movement and its look, animal associations were really common.
Like what?
People said it looked like a cute dolphin smiling, or it reminded them of whales swimming in the galaxy. They interpreted its movements as greetings or playfulness, not just programming.
They saw intention. I love that one anecdote in the source where a participant said the robot was complaining when it accidentally bumped into them.
Right. And that perception of emotion actually made the person want to engage more, not less.
That perceived intent really raises the stakes beyond just utility. I think one participant gave the strongest evidence of this bond.
Oh, and they contrasted it with quadrotors.
Yeah. They said drones with blades feel rigid and cold, clearly just a machine or tool. But if this floating robot broke, I would feel heartbroken.
Heartbroken.
Let's just sit with that for a second. We're talking about an emotional bond with a machine, which proves the design is successful not just mechanically, but emotionally. That is a seismic shift.
It is. We've moved from cold utility to genuine affective companionship. And that emotional acceptance leads us perfectly into the third research question.
Right. What do people actually envision this thing doing in their daily lives?
The co-design sessions here were so revealing. They basically identified three major roles, and all of them are rooted in the social and emotional sphere, not, surveillance or delivery.
So what was the first one?
The first role was companion. Participants sought actively addressing loneliness, providing gentle hugs because it's so soft and acting like a pet. Maybe it flies around and makes sounds when you get home.
That makes sense. And the second?
Play. Think less utilitarian, more just fun.
Yeah.
People imagine things like a dance party scenario or a game of fetch where you could gently tap it around the room.
And the third role was assistance, but not in a heavy-duty way.
No, more about alleviating daily stress. Ideas like the robot reminding you about cooking ingredients or providing a gentle wake-up call, making boring tasks more enjoyable.
This is where that spontaneous affection led to a really radical design insight from the participants, right? About the wings.
Yes. They realized the wings, which are just for propulsion now, could be used for social gestures. They called them hands.
Wings as hands. They wanted the robot to use them to hug them or to communicate.
That's huge. It shifts the function of a mechanical part from pure movement to social communication and touch. It suggests future designs should build that in.
And the researchers actually trialed a couple of these ideas based on the feedback.
They did. First, as a building guide, which shows off its unique advantage.
Ah, because it can fly over stairs.
Exactly. It can navigate multi-level layouts where a ground robot is completely stuck. It uses the whole mid-air volume of a house.
And the second trial was as a playmate.
Right. It followed the user and mirrored their arm movements to do exercises together, making workout fun and interactive.
That really highlights the core advantage, using the vertical space. When it's not active, it could just float up by the ceiling, totally out of the way.
It keeps your floor space free. It expands the whole interaction zone of a home.
So what does this all mean for the future of HRI? I mean, the Cuddle-Fish project seems to prove that by prioritizing this soft, bio-inspired design, flying robots can be transformed from these anxiety-inducing tools into safe, touchable, effective companions.
It does. That 92% rate of spontaneous touch is the metric that changes everything.
But we have to be grounded here. What are the current limitations?
Oh, for sure. The robot in the study needed a remote operator. Full autonomy isn't there yet. And because it's so light, it's very sensitive to airflow. So strictly indoors, no drafts.
And payload, I imagine. It can't carry much.
Very little. But the research stack already has plans for that. They're looking at offloading the heavy processing and batteries to a ground station that communicates wirelessly.
So the robot itself only has to carry the absolute essentials, the lightweight motors and sensors.
Exactly. The path to autonomy is clear. And if you connect that emotional bond back to the bigger picture, the potential is just immense. Imagine this perfected as a telepresence avatar.
That is a powerful idea. Think about a parent who's working overseas. They're not just on a flat screen anymore.
Right.
They could remotely control the Cuddle-Fish to physically play chase with their child, or gently pat their head, or even give them a soft hug with those wings.
That functionality, bringing a sense of actual physicality and closeness back to remote relationships, that goes so far beyond what we can do with a screen. It bridges emotional and physical distance using technology that's designed for affection first.
The future of robotics might not be about how fast or strong they are, but how gentle and soft they can be. It's about turning loneliness into spontaneous affection. That is the true potential here, and something to really think about the next time you look up and imagine what could be floating around your living room.